Welcome, everybody. My name is Dan Treiman, and I am the CEO of NEIBC. NEIBC stands for New England Israel Business Council, which is a not-for-profit organization that supports and enhances the business relationship between Israel and New England, but primarily the Boston area. And today we have a fascinating topic of discussion: Israeli technologies spearheading the next generation healthcare revolution. And indeed, it's a real revolution. And we are lucky to have 4 individuals that are really the trailblazer of that revolution. We have with us Dr. Yoram Weiss. He's Director General of Hadassah Medical Organization. We also joined by David Golan. He's a co-founder and CTO of Viz.ai, which was one of the earlier companies that started that revelation. And joining David from a technology perspective is Ido Kunst, founder and CTO of Medix.ai, as well as Yuval Baror, co-founder and CTO of Rhino Health. Just an asterisk on the Rhino Health. The management is a Boston-based company, so it's nice to have you guys. With that, without further ado, I would like to introduce David Golan to run the show. So David, the baton is yours.
Thank you, Dan, and I appreciate the opportunity to be here. And all the credit goes to Dan for initiating and organizing this. So he's behind the scenes organizing everything. So as mentioned, Dr. Weiss here is the chairman and CEO of Hadassah Hospital. He will soon start from his perspective as running a healthcare organization. What is the potential of AI and what are the hurdles that he's seeing? Then the three of us, Yuval, Ido, and myself, will each give a brief, a few minutes overview of the companies. But really, the goal is to spend most of the time in a lively discussion, because just discussing the challenges that we're seeing in this fast-growing environment, and also hopefully getting some participation from the audience, from you guys. And I'm sure that it will be a lot of fun. So, Dr. Weiss, I guess over to you.
Thank you for inviting me. And it's really a pleasure to be here with you and share with you a little bit our perspective of introducing AI systems and what are the tasks that we see ahead of us when dealing with it. And I'll start by giving a quick introduction into the hospital system that we're running, and then why are AI systems so important to us, and what is the direction and what are the challenges with AI systems that we see. So Hadassah is a hospital that has 2 campuses, both in Jerusalem at this point. One is in Kerem with 900 beds, another one in Mount Scopus, which is on the northeast of Jerusalem, 400 beds. We also have a large clinic in Tel Aviv, and we have a very high occupancy rate, which is very different than in the US. Just to give you a notion of the activity, we're treating more than 1 million patients a year, and we have about 45,000 surgical procedures performed a year, and really more than 700 ambulatory activities performed, 32,000 MRIs, and this is important for our discussion. And if we look at the infrastructure, we have 45 operating rooms, 4 angio suites, 5 cardiac catheterization laboratories, 5 MRIs, 2 PET CTs. We actually have a cyclotron, and we are producing more than 55% of the isotopes for Israel, and we have 4 linear accelerators. Now, this is important because some of these devices are actually subject to AI systems now or in the near future. When we look at the hospital, it's obvious today that there are, I say, 3 pods, and the most important one is people. Then there's the buildings, and the most important one is the software and the technology. And the idea is, since the technology is increasing in its capacity, how do we make it more accessible for people not to draw in the technology. And part of this is the introduction of AI systems. And I'll try to give a quick understanding where we are with the data related to imaging. And I'm going to focus from now on just on imaging, meaning CT and MRIs. So if we look at the imaging data, generally speaking, you can see the very quick increase in the clinical and non-clinical data that we see worldwide. And if we look just at Hadassah, we see that the MRI activity has increased by 33% over the past 5 years, and PET-CT has increased by 11%. Now, furthermore, we are now presenting very quickly to our patients at Hadassah. The patient is basically receiving at his palm or at his computer at home directly the imaging that he has done in the hospital. So the ability to provide an answer to the patient as quickly as possible is very important, especially how do we move the important part up the pile from all the others X-ray that or CTs or MRIs that have been done that are less important. So for all of these reasons, in order to allow our physicians a quicker diagnosis of critical diagnosis, secondly, how do we move stuff up the pile for X-rays, CTs, MRIs that have been done and required a quick attention, we are putting in as quickly as possible AI systems. At this point, we have 10 fully implemented imaging packages for AI systems, especially dealing with brain diagnosis and chest diagnosis of giving of chest, pneumonia, fluid, edema, obviously, and obviously also occlusion of blood vessels in the brains or bleeding in the brain, and obviously in the chest also pulmonary embolisms. If we look at the average time for implementation of an AI systems at Hadassah, it's about 1 year, and it's very, very long. And the reason is that it requires a very significant adjustment, both from legal issues, security issues, information technology and imaging issues, IRB approval, which is Institutional Review Board for those who don't know that, and commercial aspects. Because of all these reasons, what I have discovered as the CEO and previously as the director of NCARM, which is our largest campus, is that the amount of time we had to implement in order to put in place these systems require about 10 FTEs when we look at the aggregated time that we have to dedicate to implement these systems. Now, what's the reason that it's so challenging to implement AI systems these days? One of it is the increased amount of data that is being produced. Secondly, and very importantly, the complexity of integrating the AI systems both into the electronic medical record and also through our admission, transfer, and discharge systems of the hospital. The storage and connectivity costs that are incremental, and for each AI vendors, you need to address storage and connectivity efforts that are completely separate. And there also the numerous external leads to networks because of overload, which is creating a huge amount of overload on our computer system and our connection system. Now, when we look at the caregiver, and this is a very important part, and I dealt with it today, actually, just by chance, it was brought to my attention. The current AI products are fragmented, and they're creating, in a way, a disruption in the user network and user interface with the physician. Why is that? Because first of all, the user must become familiar with a very wide range and growing range of AI applications for each of the diagnoses. Then there is a need to move between different applications. And finally, for each application, we have to undergo a very delicate evaluation of the accuracy and prediction rate of the AI system on our systems. This actually may compromise the standard of care, especially the requirement of the caregiver to move with one system to the other. But looking at it from the hospital part, from the administration part, what are the problems? The problems, as I mentioned before, are legal, compliance, privacy issues, and security issues. And I can tell you that speaking 3 days ago, with a Minister of Health of a major European country, this is a major issue that all of us are dealing with at the level of country level, regional level, and each hospital. And also in our days, cybersecurity is extremely important, and the different openings that are required into our systems because of different AI systems that require connections outside of the hospital on transferring data outside of the hospital are creating actually points of attack by cyber systems. Obviously, there's also the issue of malpractice insurance, which needs to be addressed. So all of these are causing really major issues for hospitals. And for this reason, changes into the AI systems are required, and this is the part that my colleagues will try to address. Thank you.
Thank you, Ron. That's we always say that the user's perspective is priceless. This is really where it all begins and ends, not with a solution, but rather with a problem. So I'll move on to present a bit about Viz AI. I'm David. I'm the Chief Technology Officer and one of the co-founders of Viz AI. Our main mission in this world is to provide accelerate the administration of life-saving treatments to patients who need them using intelligent care coordination. So talking a bit about the high level of Viz. So we were founded in 2016 out of Stanford. So a relatively young company, but we've raised a bit over $250 million to date, and a recent round put us in as a unicorn status. We're now employing about 380 employees in 4 main geographies. In the US and Tel Aviv are the biggest concentrations, but also we have an engineering team in Portugal and EMEA headquarters in Amsterdam. And nowadays we're serving about a bit over 1,100 hospitals across the world, around the world, processing a scan every 28 seconds. So at this point, we have 8 FDA cleared products. I'll go through most of them throughout the presentation, but at this point, I have to say that our product is mature, our product is clinically validated. We have dozens of papers demonstrating the impact, and we're happy to serve this amount of patients. In terms of how Viz was founded, so this is me about 7 years ago. I'm just being discharged from Stanford Hospital. I was admitted a day earlier with a suspected stroke. I couldn't speak, I couldn't move the left side of my body. Luckily for me, it wasn't a stroke, it was a different kind. It was some sort of a migraine, a very severe migraine. But it was a very, very scary experience. So as I was discharged, a friend of mine said, hey, I have this neurosurgeon friend, Dr. Chris Nancy, who's here at Stanford. And we actually met for a beer and started talking about my experience as a patient. And Chris basically told me, David, it's a good story, but you're lucky because you're fine. And I had numerous patients die over, delays where patients would get stuck in the ER for hours after they had their imaging done, which is a very common phenomenon. We started talking about it and realized that there is a problem with how healthcare is done right now, especially in the acute care, and that we can inject technology to improve things. So we turned from a couple of scrappy Stanford students into buttoned-up entrepreneurs, and we raised some money and started diving into the wonderful and scary world of acute care. So let me tell you a bit about stroke. So stroke is the #4 killer in the Western world. It is the #1 healthcare expense. It is one of the most time-critical conditions in all of medicine, with every 1 minute of delay translating to almost 2 million dead neurons, over 4 days of disability, and over $1,000 of costs to the healthcare system. So on top of the personal tragedy for the patient and their family, it's also a huge, huge, huge burden on the healthcare system. So we have this huge issue, and the surprising thing is that most patients are not treated properly. They're not treated on time or not treated at all, which was basically Chris's experience as a doctor and my short experience as a patient. So as we started trying to understand why this is the case, we started shadowing stroke doctors in hospitals. And this is an example from one stroke system where the average time from when the patient got into the hospital on the left to when they got treated on the right was about 2 hours, a bit over 2 hours. And remember, every 1 minute is 4 days of disability. And as you start to dive into the workflow and dive into the long series of steps that needs to be taken to take care of one patient, you begin to understand how come that something can be urgent and yet not be treated on time. So a patient walks into the ED, they get into the ED, there's blood work, there's triage, there's imaging, there's processing of the imaging, there's a number of consultations that need to be done. Sometimes we need to transfer the patient to a different hospital and so on. And all the time the clock is ticking, brain cells are dying and so on. Our vision was to change the process from a long and serial and human-based process to a fast, parallel, tech-based process. Basically what this does is connect all the hospitals to the cloud, all the imaging goes to the cloud, we analyze it in real time, we identify those pathologies that matter, stroke, brain bleeds, etc., and we communicate it directly to the entire care team. So everybody gets notified at the same time through a mobile app that also provides them all the information they need. They have a viewer, they can see the scans, and implementing this at the very same system that had a bit over 2 hours of time to treatment, after a few months, they've demonstrated the time to treatment went down to 39 minutes. So this is a huge, huge, huge saving of time. And again, every 1 minute actually makes a difference. Using this data, we were able to get FDA clearance, which sort of really opened the door for a lot of the AI technologies. I'm sure most of the products that Professor Weiss mentioned are relying on our clearance as a predicate. And since then, we've been commercial in the US and recently all over the world with, as I mentioned, 1,100 hospitals and serving patients a bit over twice a minute. The most important thing from my perspective is that being in the market as long as we have, we were able to demonstrate real-world impact. So at this point, we're beyond accuracy of the algorithms, but rather demonstrating the impact of the system in terms of minutes saved, in terms of reduced days of hospitalization, in terms of reduced disability up to 40% or 50% at discharge, 40% at the 9-day follow-up, and increment in the number of patients treated. So these are patients who previously would fall between the cracks. Now the AI identifies an issue, notifies the team, the care team then reaches out and makes sure that the patients get the treatment. So I think one thing we're going to talk about is the problem of where the rubber hits the road. And I think 2017, 2018, as we were starting, we were actually one of the first, or the first company went to hospitals and says, we want to connect you to the cloud. We want you to stream all your healthcare data to the cloud, all your private and protected information to the cloud. And this required a huge, huge, huge investment in security and privacy standards. And by the way, our Chief Information Security Officer at the time was Ido Kunst, who's going to speak right after me. So, a lot of the credit for what I'm presenting here is his. And actually, this is an example of one very nice thing that Ido created, a Trust Center website where people can go and themselves explore what Viz has to offer in terms of security. And getting the first hospitals implemented, as Yoram mentioned, it's a huge effort to get legal, to get security buy-in, to get IT buy-in. So the first few installations were just really monumental efforts of the entire team. And Ido and I spent many, many nights, burning the midnight oil, talking to IT security folks in the US to get their buy-in. Nowadays, I'm happy to sort of share that, especially after COVID, there is more openness to technologies that require cloud. And I think Ido and Yuval will talk a bit about how sort of the next generation of technology and AI technology in healthcare might look like. With that, I'll stop and see if there's any questions. I will just say that if you want to experience a bit more about Viz, you can go to the App Store and search for a Viz AI training demo, or just scan the QR code that you're seeing here. We have a demo app that shows the main functionalities of Viz, and you can view some scans on your phone and explore the look and feel. If you have any physician friends, I'm sure they would be interested. And that's it, basically. So let's stop for a second, see if there's any questions, and if not, I'll hand it over to Ido. Yes, Yuval. You're muted.
Can you explain a little bit more what exactly? Congratulations on your success. It's very impressive. It's amazing, and I'm happy, first of all, that you're healthy and you didn't have any issues.
Thank you.
But can you explain a little bit more what the AI system does?
Yes.
And where the mobile phone is in the game, because this was a little confusing.
Definitely. So if we go back in time a bit, most of we're definitely not the first company to apply AI to imaging. That has been around for probably 20 plus to 30 years. No one is claiming novelty there. What Viz brought to the game was, first of all, the focus on time-critical conditions. So we look at stroke, we look at brain bleeds. It's really not about the accuracy of the read. It's not like mammography CAD, for example, where it's really about detecting the very small lesions, or lung nodules, where it's about detecting the very small nodules. That's an accuracy problem. With stroke, brain bleeds, pulmonary embolism, aortic dissection, these are trauma cases, these are emergent cases. It's really about time. So here, the value of the AI is not necessarily accuracy, it's about time, and then it's also about putting the information in front of the right person. And then you ask yourself, who is the right person? And the Viz answer to that question is, the right person is not the radiologist. Because in acute care, you want to bypass, if God forbid someone has a stroke, who do you want to get notified? The radiologist, who would then notify the surgeon, or directly to the surgeon? You want to go directly to the surgeon. And then the next question is, who is this surgeon? What is their persona in terms of product research? And as you start researching, you understand this person, unlike the radiologist, they do not sit next to the computer all day. When they are on call for 7 days straight, they're up and about in the clinic, they go shopping, they go to the kids' soccer, but they need access to imaging. So it has to be on their mobile app. It has to be mobile. Before this, these guys would go around with a suitcase, like the nuclear codes of the president, with a laptop so they can log into a VPN and see scans from wherever they are. So now they have it with, we all have this amazing machine in our pockets. Why not use it to make the data accessible? So this is really the Viz story. We have the AI that identifies in the masses of patients who needs attention. And then we have the what we call the system of action that makes the information accessible, allows the team to collaborate, decide on the next step, and really execute it much, much, much faster.
What were the obstacles to FDA approval?
Yeah, so
They've been pretty skeptical about AI.
So it's a good question. Actually, our process with the FDA was super positive and collaborative. The big hurdle was early on, because we came in presenting essentially a very, very new idea. FDA, there's a division that deals with imaging devices, software devices for radiology. They have this paradigm of radiologists who sit in front of a computer and gets the outputs of the software. And now here we come and we say, it's not going to the radiologist. In fact, it might go to someone who's like associated with a different hospital, and they're not even at home. Right? So for FDA, it was a bit of a leap to, but once there was an understanding, it's actually a moment we all fondly remember, because we went there, we flew to Washington, DC, and we're talking about, and at some point there was like an aha moment, and they said, oh, now we get it. This is going to be really good for patients, but we have to do it de novo. You cannot fit into a 510K because it's an entirely new thing. And from that moment on, it was a super, super, super collaborative process. It took us start to finish 9 months to get the clearance, which is really, really record time, especially for de novo. And again, FDA was super supportive. I will even say that they urged us to send them stuff over the weekend sometimes, so they could go over it and like really, it was a wonderfully collaborative process. Ido, you're next.
Okay. So let me share my screen. Okay, so hi everyone. First, I want to thank NEIBC and Dan for inviting us to speak to you. For those of you who don't know me, so my name is Ido Kunst. I'm 47 years old. I started coding at age 6 and had my first job at age 16 as a programmer. Throughout my career, I've engaged in what I believe are some groundbreaking startups, either as co-founder or as a member of the initial team. Some of those did awesome, some are still doing awesome, like Viz.ai, and some ended miserably. The one experience I always like to talk about is the one that I have co-founded in 2003. We were the first to stream live television over the internet and already started to build our user base. But about a year later, we got a call from Channel 10, the Israeli Channel 10, asking us to come for an urgent meeting. And on that meeting, we quickly learned that the content providers are asking more money from Channel 10 for broadcasting over additional mediums. Apparently, Channel 10 ran an internal discussion and brainstorming, and they believed that it was not worth the investment since they saw no future in this medium. So we went to other investors hoping to get some money, but all of those we met believe there is no future in broadcasting television and movies over the internet. According to them, no one will ever watch television using their cell phones and mobile devices. So we had to close shop, and for those of you who are not familiar with recent history, Netflix started in 1997 as a mail-based movie rental business. It was only in 2003, about 3 years after we closed, that Netflix launched their streaming services. They only had 1,000 films at that time, but because only in mid-2007 they have recruited Anthony Wood to build what's called Netflix Player. So while this experience helped me mold my conceptions on how short-sighted some investors and experts can be, I had to move on to and in the next 10 years or so, I was working for Homeland Security Organization, doing some challenging roles around the globe. And this what really brought me into the world of security and how heavily security is needed in so many areas. So in mid-late 2014, I decided to leave all that behind and move back to Israel. And in mid-2017, I met David Golan, as he mentioned, and joined Viz.ai as a member of the initial team. Together, we worked to move the company from seed to round B. And while working on Viz.ai, the understanding of Medix AI came to be. As David mentioned, we had a lot of, I'm trying to change, so I will not do a repeating of what Professor Weiss and David already told you. So we had a huge process going to understand what is needed in order to get into bed with healthcare organizations. And I think we very quickly realized that there are two factors that are being considered. The first is money and data. The second is data. So if you're not bringing money to hospitals, then you are not good for hospitals. Hospitals, especially now after COVID-19, they are bleeding money. They're losing a lot of money, and they need the money. And how? And this needs no explanation why they need so much money, because without the money they cannot exist. But anyhow, so they need solutions like Viz.ai and other companies that generate revenues for them. They generate it either by creating new treatments or accelerating the treatment or providing a better treatment, and then less negligence lawsuits, or by finding new ways to build the customers. But the biggest problem is the data. They in order to do all that and bring all those new revenue streamers, they need to share data with those companies, those vendors, either online, via the cloud, or locally. And this data is very sensitive. It's so sensitive because we see, and this is what I brought from the Homeland Security experience, we see all the time attacks that made by countries on hospital and healthcare organizations, and for reasons that need not a lot of explanations. And so there is some kind of let's say there is some kind of a collusion between the need to bring on and very fast those money generator and how to protect the data. And they also don't have a lot of choices, because the legal perspective, like from what's going on around the world, we see a lot of laws passing, like the HIPAA and the ITEC and the GDPR, who are meant to protect data of patient. So this is actually what's lingering all the process of onboarding new AI vendors, as both Professor Weiss and David mentioned. So and to explain how long it takes, we saw companies, and now as Medics AI, that sometimes they signed some initial contract with the prospective customer, their healthcare organization. It takes them 2 months to contract the agreement, to get a so-called green light to start do the integration into the hospital, and for 9 months, sometimes even more, they are failing to meet the requirement of the hospital, into a point that some of the deals are falling and terminating. So this is like where Medics AI came to be. Medics AI, the idea is we want to solve this problem by helping healthcare organization onboard faster those revenue generators for them, and helping vendors to meet the requirement that healthcare organization needs in order to be able to board them, by creating a platform that singly connects with the hospital, getting all the data that the vendors will need, de-identify the data according to the requirements set by the HIPAA privacy rules, the what's called the safe harbor method, the 18 characters there, and then distribute it securely to the vendors, so they can do their processing and return the data to the hospital in a way that solves both the problems that were described by Professor Weiss, and allow faster onboarding, as I said. So this is, without repeating some of the already things that were said, this is what we believe can help the problem that currently puts into still some of the deals in the industry.
Questions for Ido? I have a short question. If you had to choose one thing, what are the hospitals prioritizing? Income, or like reducing spend, or increasing income, or getting the security and compliance in order? What is the one thing that you think is top priority?
The biggest showstopper, of course, is security. The hospitals will not risk, I believe, security for additional income, because that may, and I think this question can be better if directed to Professor Weiss, I think at least in the States, the penalties that HIPAA may put on you and GDPR and other rules around the globe, when it comes to a security breach, it's so it can really cost it can take the hospital's entire revenue for that year, and anyway they're now losing a lot of money post-COVID. So I think they will not risk. I think they will not risk security at this point, and I think that's what the lingering or breaking most of the deals out there.
No, I have a quick question for you, Ido.
Yeah.
The company, from the business point of view, what stage is the technology? Is it in beta site? Is it you have customers? In terms of the business, what stage of investment are you in? What stage are you with the FDA approval and so forth?
So currently we don't have to deal with the FDA. We are building our what's called the MVP as an alpha site in Hadassah, and trying to bring companies like similar to Viz.ai to Hadassah in a way that it will make sure that it will not compromise the security of Hadassah's data. So we are a bootstrapped company. We are working on our seed investment, and we currently building together with our advisory board the strategy of how to penetrate and to the beta sites that are piling up in the States. How to bring them a better MVP.
Ido, question about the scope of the image analysis. Is the scope limited to the imaging data coming from the imaging devices, or it also includes context from EMR, EHR information?
So when we met first time our advisory board, I wanted to show that we are not one trick pony, that we can do it all, and we can deal with all the data the hospital has. And we got a very good advice saying, listen, 70% of the data, and now we are talking about like 4 petabytes of data that is created each year, and it's growing each year by about 40%. Is coming from CT and MRI and all those imaging devices. This is what's clogging our network. This is what causing us the biggest fear. So if you can save, or if you can find a way to release us from this burden, focus on that first, and then you can move on. So I think once we can fix that, we are not limited to any for a specific type of format. But yes, currently the first stage we are focusing on DICOM and on data that comes from either the PACS or from directly from the CT, MRI, X-ray, ultrasound, and all those models.
Okay.
This is a question for both David and Ido. How do you find vendors of those PACS systems, and ultimately with Epic and Cerner when you start interfacing with EMRs?
I'll answer very briefly, because we interact directly with the modality to save time. So we hardly ever do that. And when we do, it's typically okay, but Ido probably has a more elaborate answer.
So from our solution, the way we structure the solution, we don't have to deal with those since they're using a DICOM format. We just know how to read the data directly, the DICOM, and convert it, split the image data from the other tags, de-identify the tags, and send it. So we don't have to deal with those companies, and I think that's per the request of the hospitals that we are already talking to. They are afraid that we will, if this type of solution will be constrained because we need to their collaboration, or the CT and MRI and PACS manufacturer, then most likely they can fail us, because from one perspective we might make them a little bit less dependent on those manufacturers, the hospitals, the healthcare organization. So I'm not sure they will be very delighted to cooperate with us. So we found a working solution how to build our product without needing them.
Okay, thanks. And I think we'll move on to Yuval Baror, our third speaker. So Yuval, maybe you can introduce yourself in 2 sentences and then
sure.
take this stage.
Thanks, David, and thanks, Dan, for putting this STEAM forum together. So as I share my screen, I'll just give a few sentences. My name is Yuval Baror. I'm the co-founder and CTO of Rhino Health. Similarly to David and Chris, the founders of Viz, we are a technologist and a recovering physician who have come together to co-found Rhino Health. And our goal at Rhino Health is to accelerate the impact of AI in healthcare while trying to solve some of these challenges that we've been hearing about today of keeping data safe. And our approach is complementary, I think, to the approach that Ido has discussed here, where we use technology called federated learning. And in general, our approach is just, instead of moving the data around to the cloud, where it is difficult to maintain its safety and it clogs the network, etc., said, you know what, let's just leave the data where it is at the hospital sites. So I think we've heard quite a bit about how innovation and AI is really transforming the field of medicine as we know it. There are now not just Viz AI trying to innovate here and deliver solutions with AI in healthcare, but there are hundreds and thousands of companies that are now working on AI solutions for healthcare, getting FDA clearance, and trying to really penetrate these different hospital systems to build and deliver their solutions to improve the healthcare that we receive as patients around the world. But as you heard from Professor Weiss, it's not as easy as it seems, and there are lots of challenges in both building and deploying these different AI solutions across the world in many different sites. So our approach is, okay, it's really difficult to take this data and move it from these hospital systems to the cloud and centralize everything there. Let's keep the data at rest within the hospital networks. We're leveraging a technology that was popularized by Google around 2017 called federated learning, which essentially says, instead of moving all the data into one place in the cloud, let's bring the computation to the data at the different sites. So that's kind of the high level. I won't go into the details of how federated learning works. Happy to dive into that with anyone who's interested. But the general concept is that you're able to train AI models and build solutions that are based on AI without ever having to move any of the data from the individual hospital sites into the cloud. Instead, you take the model and allow the model to be trained locally at each site. So a lot of the advantages of using federated learning and keeping data at rest are, this solves a lot of the challenges that you heard Professor Weiss and David talk about, where there are far less challenges with regulation, there's far less challenges with networks being clogged and having to these security risks with different IT organizations and legal and compliance at the hospitals. And it allows the model developers to actually work with a much larger and more diverse data set, because they're able to access data not at a single hospital site, but at many different hospital sites around the world. There's a really interesting research that was published around the end of 2020 in JAMA, saying that over 90% of healthcare AI in the US is developed with data in 3 states in the US. New York, Massachusetts, and California. And that kind of brings to light some question on, wait, but what if someone from Florida goes to a hospital and encounters this AI algorithm? Like, what happens then? There's really a need for developing AI solutions with much broader, more diverse, and continuously updating data sets. We believe that federated learning and keeping data at rest is a really good solution for how to do that. And hence we've built a platform that allows the data to stay at each hospital site so that you can essentially run the compute, train the models, and run all your pre-processing and everything that needs to happen at each site with a central orchestration in the cloud. So for the model developers, they kind of access the Rhino Health network and can work with data at multiple different sites around the world to do their end-to-end AI project development. We are already deployed at leading medical centers around the world with an ever-growing footprint with different hospital centers around the world, and are actively working with both academia, government, and industry on different projects to leverage our network of different hospital centers to be able to do innovation with protecting data privacy across different research and rare diseases, research and developing models for in different therapeutic specialties, oncology, radiology, genomics, etc. And working with industry both on developing algorithms as well as validating algorithms. You heard Dr. Weiss say, hey, okay, there's an AI solution that someone is trying to sell me. How do I know that it worked with my hospital's data? So allowing hospitals to validate these solutions without having to do a lot of IT installations or sending a bunch of data to the cloud. So that's what we're trying to do, and hopefully helping to accelerate some of the innovation in healthcare around the world. Thanks.
Thanks, Yuval. I have one question similar to the question I asked Ido. I would love to hear your perspective. Between the keeping the data private and safe and capitalizing on it, which one do you feel is the biggest driver for hospitals? And does this change in different localities and geographies?
Yeah, that's a fantastic question. I think, as you mentioned, there's really this kind of urge for hospitals now, especially as we've seen hospitals bleeding money, they're losing money, and they really need to capitalize this search for how to find additional revenue streams in hospitals, how to become more efficient, et cetera. At the same time, so they want to make sure that they're protecting data privacy. So there's always this balance. What we're seeing is this really, there's this very lucrative revenue channel from being able to monetize the data asset that hospitals have, while at the same time, they don't want to lose control over that data asset by sending this data to multiple different vendors in the cloud. And then they send that data, they don't really know what happens later, what that data is used for, what the privacy and security practices of different vendors are. Not everyone is as secure as Viz AI. There are many vendors that they claim that they're cool and they have different security standards, et cetera, but you never know when they can be breached, and then this hospital's data will just be spread all over the web.
Thanks.
Yuval, how do you assure semantic integrity over time across the different sources?
That's a really good question. So one of the biggest challenges with working with data across multiple sites is data harmonization, making sure that we have the same format, the same type of data, the same semantics across the different sites. So AI will say this is a challenge for AI in general. This is not just a challenge of building the models. I have an AI model that I've developed with data from, let's say, a hospital in Israel, a Sheba Medical Center. Now I want to deploy this model at Mass General. Like that, the data model that at each of these sites is very different. So even as a model developer, when I'm building my model, I need to account for the differences in data across these different sites. One of the capabilities that our platform tries to solve for is these different data ETLs, like trying to transform and prepare this data and harmonize it across the different sites. So allowing the model developer to build this capability of, okay, I know that my data at NGH has this specific data format and at Sheba has this other data format. I'm going to build a pipeline that will transform the data into a common format at each of my hospital sites so that my model can then see a common data format, a common data dictionary, and can work with that.
I agree with you with a problem statement, but let's go to the solution statement, your solution statement, where semantic integrity, it is tied to format, but the core semantic integrity is not format. The core is meaning, the core is content. So how do you solve the semantic integrity? We understand the problem.
Yep. So I will say that our solution is the infrastructure. For this, we don't solve for the semantic integrity directly. We provide the tools for the model developers to develop their pipelines, to develop their harmonization in order to be able to solve the semantic integrity. We don't claim that we have, this silver bullet. Give me your, EHR, I'll transform it into a common data format, data model, and semantic model, et cetera, across all the world. Like, I don't believe that these silver bullets exist. We provide the infrastructure to allow model developers and commercial companies, et cetera, to develop their harmonization engines, their ETL pipelines, et cetera, to be able to harmonize that data.
That makes a lot of sense. Thank you.
Yuval, thanks so much. I had a question about the rare disease use case.
Mm-hmm.
In order to be super effective, you really have to reach the largest footprint of patients. So, how much effort, expense, time does it take to sort of get plugged in? Because if it's great if you're at a handful of academic medical centers, but if you have a disease that has 100 patients a year, they're unlikely to be there.
Yep, that's absolutely true. And that's why I think rare diseases are a really interesting use case for federated learning and in general distributed compute, because you can go to Mayo, you can go to MGH. Yeah, cool. You'll have like a bunch of patients there, but as you said, you won't necessarily have the right patients or enough patients that have that rare disease. One of our main areas of focus since founding the company a bit less than 2 years ago has been to expand our footprint of hospital installations in order to be able to reach the largest data set of healthcare data, so that when you go and search through the Rhino Health Network in order to find a rare disease or any data query that you will have the largest amount of data that is accessible through our network. We're constantly expanding that network, and we're obviously happy to find additional data sources. Just as you said, the larger the data set, the better for the rare diseases and in general for many AI solutions today in healthcare.
Do you use de-identify data for prospecting in order to figure out where you should be kind of behind the firewall?
A lot of times, great question. So a lot of times we'll work directly with the de-identified data in order to perform these kind of initial feasibility and data searches. So we can go and say, okay, yeah, where across the Rhino Health Network is there data that meets my criteria? How many patients are there at different sites that meet these criteria? And then from there, you can start kind of take the next step to work with those specific sites and start your project.
Hey,
Great,
Lior, we have Lior raising his hand.
Thank you. Just a small technical question. So is the model training done on the local hospital network, or is it on the cloud? I guess I missed that.
Yeah, that's a good question. The way that federated learning works is that most of the model training happens within the hospital network at the edge. We make sure that there is sufficiently strong hardware at each of these installations to be able to support training, so GPUs and things like that. And then there is an aggregation step that happens in the cloud where only a subset of the model weights are shared from each of these edge devices to the cloud to perform aggregation that is much more lightweight from the computational side, and also doesn't compromise patient data privacy because it's only a subset of weights, and there are many different mechanisms for ensuring that data does not leak through those weights.
Thank you.
I have a question for Dr. Weiss. So as over the last 6 years, you mentioned you have working with 10 different AI vendors. Most AI applications have been very narrow, working in stroke, working in lungs. Now we're seeing the next generation of companies like Medix and Rhino are sort of providing IT infrastructure that support a lot of different departments in the hospital. Who do you think should pay for this? And who should be the decision maker when going out to purchase something like that?
So first of all, it depends what the solution is, but generally speaking, I think there will be a shared distribution between these platforms. Basically, the way I see it, will require a distribution of payment, both, I would say the following. In Israel, it will be the hospitals and maybe the developers or the AI companies. I think that in other systems where it's the US, etc., and I think Ido mentioned it, at the end of the day, it will be the insurance companies. So the burden of payment will be moved towards the insurers. The difference of the healthcare system in Israel is different because in Israel, we have a universal healthcare. So basically, the government is covering all the expenses. So it will, at the end, the payment, the coverage for the expenses for introduction of AI system and these bridging systems, let's call them, either the one Yuval presented or Ido, will be put upon the hospitals, and maybe also on the end AI companies that will share the platform, which I think should share some of the burden, because either one of these systems provide a bridge to the hospital for the hospitals and the physicians to use it in a much more efficient way. That's the way I see it.
Thanks.
I think that I can add something to Professor Weiss. I think it depends on the approach. I think the approach that Medics AI, for example, is trying to bring, where data is being streamed into the cloud, de-identified, and then being processed there and coming back. The great advantage when you're using a cloud-based services like a Google Clouding, Amazon Web Services, and Microsoft is that you know exactly how much it costs, the processing and the data transfer and the data storage, so you can get an exact amount. And this exact amount can be, matched to a specific patient, and therefore can be billable. Unlike current situation when you have, processors and GPUs and storage that is running inside the hospital, what's called on-premises on the data center, and you pay for it annually. For buying more additional storage, you're paying for buying more hardware. You don't know how to divide that plus your stuff, the FTE, as Yoram mentioned before, and how to bill it in a more exact way or more accurate per patient.
Thanks. Yuval, maybe you have also a perspective as you're bringing hardware to hospitals and getting it costs a lot of money.
So I'll say first that we also work with hardware at hospitals within their on-prem data centers, but also what we're seeing is a trend with many hospitals working with cloud providers where a subset or a large amount of their data will also be available in their cloud accounts. And that also is very helpful, at least for us. It makes our life easier where the data still sits within the hospital's cloud account. They don't want to share that to someone else, but it makes it much easier to then, as Ido mentioned, to measure the usage, to build out new, larger infrastructure, et cetera, to support more computation. So definitely see that trend happening. But yes, a lot of the hospitals still have their kind of on-prem IT, but more and more of them really have sophisticated data centers with GPUs, with large servers, working with leading providers, and not just for developing new AI, but for some of their internal use cases of, they want to have their AI solutions deployed in their production environment, and sometimes don't want to have this reliance on their production environment running in the cloud. So that's another trend that we're seeing.
Thanks. If anyone from the audience has additional questions, this would be a good time. I know, Dan, maybe you have a question.
No, I have to process the data.
David, I think there's a question for you in the chat regarding the size of your initial training set and how do you update your model on an ongoing basis?
Yes, that's a wonderful question. I mean, it's a bit out of the context of this webinar, but our initial data set was in the hundreds to 1,000 scans, and we've definitely grown since. Now Viz has more data than we know what to do with, and there's FDA protocols for how you determine what changes can be done to a model or any medical device, and we follow them and update as needed. Definitely, the performance has changed over time. Leo, I see you're raising your hand.
Yes, thank you. Actually, a question for you, David. So you've mentioned that your product is more about kind of improving speed and not dealing with accuracy, but for me, let's say in your example, as a patient, you want to make sure that the false positive is not too high. So I guess not to go into probably too much of your secrets, but if you can share about, a little bit about accuracy or
yeah, definitely.
Positive, yeah.
So I mean that's definitely not a secret. We have a lot of publications, and it depends on the algorithm, but our accuracies are in the range of about 90-ish, 93 to 97% sensitivity and specificity, depending on the actual product. I think you've really stumbled upon an important point, and every time when people bring up accuracy, I want to sort of focus the conversation about really the use cases, because it ties the cost of quote unquote of a false positive or a false negative really changes based on the context. And for example, when we started talking to physicians, they all said, we want very high sensitivity. We want to capture all strokes. We don't care about false positives. We are fine with false positives. We don't want any false negatives. But especially if you're dealing with these low prevalence conditions, even if your performance is high, you will have a lot of, if your false positive rate is even 1%, a lot of the alerts will be false positive. It's called a positive predictive value paradox. You have this sort of stroke given an alert is a different probability to alert given stroke, right? And what happened is, as we launched, for example, a lot of the users complained that they would get too many false alerts and be woken up in the middle of the night over nothing. And the accuracy of the algorithm was high, but the positive predictive value was not high enough. So what we understood is that it's really not just about the nominal accuracy, it's also about the user experience. And then you have to start, for example, we defined as a sort of a rule of thumb, learned on the hard way, that we need 4 out of 5 alerts to be true for the users to gain trust in the system. Right? Otherwise, they don't have the trust and they would not wake up in the middle of the night over this alert. And then, what good does the system do? It does no good. So in some circumstances, you would actually, in the short term, trade false positives for false negatives to make sure you have user engagement, that you have their attention, then gradually improve the algorithm over time. There is some non-trivial, at least for us, it was non-trivial lessons learned.
Thank you.
David, are you offering some sort of a maybe configurable model of trust? If I'm the clinician, right? Do you provide me any tool that I can adapt the experience?
Yeah. So the answer is unfortunately no. I think it's a wonderful idea. We had this early on. We had this notion of a Superman persona versus a Batman persona. Superman only deals with the biggest villains, and Batman fights every single criminal.
But this is the CTO decision. That's not the user decision.
But the real decision in this case, the real decision maker is the FDA, and the FDA said we're going to allow only a single configuration, and this is what that we currently have. And in the future, I'm sure there will be more ways to configure and give more power to the user. But right now, what the regulation allows is a single operating.
So I have a question for you, David.
Okay.
So from your experience, you're saying that you are now over 1,000 hospitals, and from the perspective of what you know versus when we started, do you see a faster way? Because you said that now post-COVID security is a little bit lighter, but do you see a faster way to onboard to new hospital, or do you think, or do you believe you could have been with many more hospitals if you had the burden of the security removed somehow? Or
I think the other way around. I think, at least for Viz, so we sort of went all in, right? We said, we want the patient's data in the mobile phone, understanding the users are going to have the mobile app, they're going to chat, there's going to be patients' names, and so we went all in. And I think many applications don't require this level of, data visibility. And then there's, people can do, you can think of very interesting things like product-led growth, where people can maybe download a Docker container and install it without you even knowing, and you get this sort of organic growth. But specifically for Viz, PHI in the app was a must, and therefore the high security was a must. I know you were there, you did most of the work. Maybe we overdid it. I have no way to say. I like to say now it's very easy to look at decisions that were made and sort of beat yourself up about it. But what I'm trying to say to everybody is because the company is doing well, it means every decision was the right decision. Even the wrong decisions were the right decisions. Because who knows, what the alternative path could have been like. So at this point, I think we made the right calls. I think nowadays, many use cases might benefit from this product-led growth approach, and self-service is very exciting. It's less applicable for Viz, but if I were starting a business now in software AI, I would consider how I might do something like that. Okay, Dan, I think we're approaching the end of our time.
That's great. There are no more questions. Maybe we'll close now by saying thank you to the audience. And for sure, thank you very much to the panelists, from Dr. Yoram Weiss, David Golan, Ido Kunz, and Yuval Bar-Or. I really appreciate your participation. Thank you very much.
Thank you.
Thank you, and thanks, Dan, for taking the lead and making this happen. And thanks
Indeed.
everybody who joined and participated.